Okay, guys, good evening once again. Today we are going to be looking at, well, not so much of a new topic. We're still continuing on the topic of equation, but today we're going to now look at simultaneous equation. Anybody have any idea what we mean by simultaneous equation? What does it mean? Anybody know what this topic is really about? Do you want to guess? Do you want to just make a wild guess and tell me what you think? How about you, Miss Waysam?
Sir, from last class, I think I recall you saying simultaneous equation is when we have like more than one we do more than one procedure. Well, procedure is not the word.
Well, I know what you're trying to say, but I guess it's stuck somewhere up in your head. Miss Green, would you like to try?
Sir, when you use formula to find the x and y values.
Use a formula to find the x and y. All right. So you know what an equation is already. What's an equation? Anybody know what an equation is?
So when it's equal, so you have a balance.
When what is equal? All right, so an equation is really a mathematical statement which expresses balance, and it does so with the use of an equal sign. And then you have a left side and a right side of the equal sign, and it is similar to that of a balance scale in that both sides have to be balanced, right? All right, now, so we have been working with equations, so you would be familiar with equations. Today we are looking at simultaneous equations where we now have, instead of just a single equation that we are working with, we may be working with more than one equation. So usually in the previous lesson, we would be solving a single equation, trying to find the value of the unknown. And in most cases, we use X for our unknown, but your unknown can be any letter that you choose it to be. Now, in simple equations, you generally only have one unknown, right? And so you're trying to solve for that unknown, find what that value, the value is for that unknown. So we generally move across everything numeric on one side of the equation and keep that unknown to the left. We calculate the side with the numeric values, and whatever that works out to be will give you your solution for your unknown. All right, so you know an equation follows a number of principles. Whatever you do with one side, you have to do the same thing to the other side in order to maintain balance. Now, as I said, simultaneous equations, we're working with more than one equation. So in most of the cases, we'll be working with two equations, but it can have more than two, it can have more than three, and so on. But for your purpose at this level, you'll only be working with two. right? Now, so we have our objectives here. I'm just going to briefly run through them. So your objective, you should be able to define simultaneous equation as a system of equation which x and y's have the same values in them and can be solved simultaneously. And simultaneous, another word you can think of for simultaneous is together, right? So, so you're solving both equations together at once. So that's what I mean by simultaneous. All right, so while we are solving one, we are automatically solving the other one. All right, so the second objective, you should be able to list the techniques used to solve system of equations, which is what we refer to as simultaneous equation. You should be able to solve system of two equations using elimination method. All right, so jumping into our topic. So first, I want you to consider these two equations. Now, one of the reasons why we want to use the method of simultaneous equation, if you notice, as I've said before, simple equation only have one variable. How many variables are in these equations?
So repeat.
How many variables are in these equations?
2, sir. X and Y.
X and Y. Now, if you should try to solve one of these equations, for instance, if you try to solve equation 1, what would happen?
Sir, it all depends on what we need to be the subject.
All right, so I'm going to let you try to figure out that for a little bit. So just try and solve equation 1 by itself and try to solve for a value of x and a value of y and see what happens. So
Okay.
I'll give you 2 or 3 minutes to do that. And then now you tell me what it is that you have discovered. All right, go ahead. Ms. Green, have you been able to work out any value for x or y? Ms. Green? All right, Ms. Wisdom, have you been able to work out any values for x and y?
Sir, for the first one, I got 13 minus 3y over 2, and then that would be for x. And then for y, 13 minus 2x over 3.
Okay, Ms. Green, have you worked out any value?
So it's not going to work.
Oh, it's not working. All right, Ms. Wisdom, would you consider what you got as a solution for x or y?
Or no, not really. Because at the top there's like an equation by itself.
Right. So the problem that you find yourself in is that you are not able to say exactly what the value for X is. And you're not able to say exactly what the value for Y is, because you're trying to solve two variables in one equation. So without knowing what one is, you won't be able to find a value for the other. And so this is the conundrum that we have when we have a single equation with more than one variable in it. However, if we decide to solve equation like these together with another equation where X and Y has the same value, then we can come up with a method of solving it. And we have several methods that we can use to solve simultaneous equation. And so that's what we're going to be doing today. We're going to first look at the elimination method. A matter of fact, we have 4 that you will become familiar with. One you can solve by graph. Now, to solve it by graph, you would plot both equations on the same graph, and wherever they intersect, you find the value of X and Y at that point of intersection. Right? So you would have been a little familiar with that when you were doing graph. Once you plot 2 equations on the same graph and they cross, wherever they cross, you find the points at that and read the value of X and the value for Y, and you would have gotten the solution. So if you plot these 2 equations on a graph and find that point where they cross, look for the X coordinate and the Y coordinate at that point. That's one way of solving this equation. Now, another method that we may come across, let me just flip through and then I'll look at the method. All right, so there are 2 unknowns, X and Y, in both equations. Now, the solutions to the equations are values of X and Y for which X and Y have the same values in both. So now the reason why we can solve these 2 equations together or simultaneously is because whatever value X has in the first equation, it's the same value X has in the second equation. And likewise, whatever value Y has in the first equation, it's the same value it has in the second equation. So that's a condition that you have to actually observe. You have to know that X and Y values are the same in both equations. All right, now, so equations which X and Y have the same values in both can be solved simultaneously, and so the equations are called simultaneous equations. Now, solving a linear simultaneous equation. Now remember, when we say linear, what we mean by linear is that an equation that, when plotted on a graph, will give you a straight line. So if we're talking about linear simultaneous equation, it means that the 2 equations are linear. Each of them, when you plot them on a graph, you will get a straight line. Now, there are 4 methods that we are going to that you will be able to apply. Now, as I said, you would have known how to do the graph. So the other method that we want to look at, 1 is the elimination method. 2, substitution method. Now, the elimination method is very, what I must say, it is very adequate when we are solving linear equation. But as in the case of linear equations, we also have equation that we consider nonlinear. And a nonlinear equation is an equation such as a quadratic equation. When you plot it on a graph, you will get a curve instead of a line. And so those equations are called nonlinear equations. So you have simultaneous equations that you may have one linear equation and one nonlinear equation. When you have that condition, it is not recommended that you use elimination method because it may not work, right? So what would be more appropriate for nonlinear equations or nonlinear simultaneous equations would be the substitution method. So we're first going to be looking at elimination method using linear equation, and later on we look at substitution method where we now have nonlinear equations. All right, so we can use the elimination method, and that is specifically when we have linear equations, right? So it is important that you note that this method will work only when you have linear equations. All right, and the substitution method is when you have nonlinear. So this would be for nonlinear form. All right, so you should bear that in mind. All right, so the next method that we can use when we are solving simultaneous equation, we can use the matrix method. Now, we will see the matrix method when we are doing matrices, which we may probably start at tomorrow or the other day after tomorrow. So we will also see how we can solve simultaneous equation using the matrix method. And graphically, I had mentioned before that you can plot both equations on the graph, look at the point of intersection, find what the x coordinate is and what the y coordinate is at that point, and those give you the solutions. All right, so these are the 4 methods that you should be able to apply. All right. We're now going to start off looking at the elimination method. Before we start any example, there are some steps that I want to highlight in carrying out the process of the elimination method. So step 1. Now, when you have 2 equations and you have to solve them together, now, as the word elimination suggests, anybody knows what the word elimination means?
Get rid of, sir.
Get rid, right. So as the word says, elimination method, what it really means is that in order to solve for one of your unknowns, you first need to get rid of one of them. And once you get rid of one, you can solve the one that remains. And then after you solve that one, then you can resubstitute that value that you get after you solve, and then solve for the other one. All right, so the first step in the elimination method is to decide which of the unknown you want to eliminate in order to solve for the one that remains. So you have 2 unknowns, x and y. So you need to choose one of them to get rid of, and whatever the other one is, you solve after you get rid of that one. All right, so that's the first step, choosing the unknown to be eliminated. And so the second step, after you choose the unknown to be eliminated, in order to eliminate that unknown, so you choose the unknown to be eliminated, but in order to eliminate it, you have to make the coefficient of that unknown be the same in both equations. Now, what do I mean by that? So let's say, for instance, you have, let's say that we have the equation 3x plus 5y is equal, say 15. And that's one of the equations. And let's say the other equation is x plus 2y equal, let's say 6. All right, let us say, I'm just using a random number. So let us say 10. Now, these are the two equations that we have. We have two unknowns, x and y. We are going to decide which one of them we want to get rid of. And say, let's say we decide to get rid of the x. Now, in order to be able to get rid of x, the coefficient of x has to be the same in both equations. Anybody remember what I mean by coefficient? When I say coefficient, what it is?
Number, sir.
Huh?
Number.
When you say number, is it just number?
Numerical value.
No, not just numerical value. When you say coefficient, we are really referring to
The number before.
Yeah, we're referring to a number that is attached to a letter.
Yes, sir.
So the coefficient of x here would be 3 in the first equation. And in the second equation, what would be the coefficient of x?
1, sir.
1, right? Even though we don't see a 1, we know that there's always an invisible one there, right? What about y? What is the coefficient of y in the first equation?
5.
5. Now, what about the coefficient of y in the second equation?
2, sir.
2. Now, if you look at both unknowns, when you look in both equations of the unknowns, are the coefficient the same for x in both equations?
No, sir.
Are the coefficient the same for y in both equations?
No, sir.
No. So what we have to do, once we decide which one of them we want to eliminate, so let's say we choose x. So we decide that we want to eliminate x, then our next step, which is step 2, is to make the coefficient of x the same in both equations. Everybody understand what I'm saying? Is that clear, guys? So
Sir, go over one time.
I'm saying that first we decide which one of the unknown, whether x or y, decide which one you want to get rid of. So in this case, I'm saying, suppose the first step, we choose which one we want to get rid of. And let's say that's step 1. So we choose to get rid of x. The next step is to make sure that the x coordinates are the same. Now, when you look at the x in the first equation, the coordinates of x in the first equation, it is 3. When you look at the coordinates of it in the second equation, it is 1. So clearly they are not the same. So when they are not the same, now we have to make them the same. And so the question now is, how do we make the coefficients the same in both equations. Right, so that's step 2. Now, any idea how we can make the two x coefficient the same? Any idea?
Sir, multiply.
What you would multiply by?
The first one 3 times 1, and the second one 1 times 3.
All right, so when you say the first one, you're referring to the equation
3x.
1.
Yes, sir.
We use these numbers with these dotted lines to label our equation. So the first one we refer to as equation 1, the next one is equation 2, and as we create new equation, we can label them 3, 4, 5, etc. All right, so in this case, you are saying that if we multiply equation 1 by what?
1, sir.
All right. What would we achieve though if we multiply equation 1 by 1? Would we really achieve?
No, sir, not 1. No, man, the 3x me are talking, sir, so that multiply the 1 times the 3.
Yeah, but what would you achieve when you do that?
We'll get back 3.
Yeah, so that means you don't need to multiply. It's still going to remain 3. So you would really need to multiply. If you're going to multiply by 1, it would make a difference.
Oh, so we'll just focus on the second equation and then getting it to be 3.
Second one, right? So
Okay.
what you have to now do is think about multiplying the second equation with the same coefficients that is in the first. So you want now to make this x down here to have a 3x to become 3x. So you multiply the second equation by 3. Now remember, it's an equation. And so in order to maintain balance in an equation, you have to multiply everything in
by
the equation by 3. Right? So now when we multiply out everything in the second equation by 3, we're going to get 3x for this one. What we get for the second one?
6y.
6y. What we get for the
Equal to 30.
Equal to 30. Now, in order not to confuse this new equation that we have created, then we have to attach a label to it. So we are going to call this now equation 3. Right? Because this equation is a new equation that we created by multiplying equation 2 by 3. All right, so what we do next, so that would be the second step. So we would have made the coefficients the same for x in both equations. So our next step now in the process. All right, so this here that I have here is just explaining to you how you can go about making the coefficients of the unknown the same. So this may be done by multiplying or dividing one equation by a number to make the coefficient the same as the other equation, right? So jumping along to step 3 now. So step 3 now said that we are now going to either add or subtract. Now it means that you're going to do either add or subtract. So it means that you cannot do both, you know. You have to decide which one you're going to do. You're either going to add or subtract. Now, adding or subtracting